Hello students, today we are going to discuss the last part of the triangles chapter, that is the Pythagoras theorem and problems based on it. So in this video we'll just look into Pythagoras theorem. Pythagoras is the person who found this or who proved this theorem. So Pythagoras theorem. Okay. So what is Pythagoras theorem? For that, let's take a right angle triangle. So what is a right angle triangle? We have already discussed in the basics of triangles. Let's take a right angle triangle like this. Is this a right angle triangle now? No, we have to symbolically mention it. Let's say the right angle is at B. Okay. So this is a right angle triangle. The side opposite to 90 degree, that is the longest side, is known as the hypotenuse. Okay, it is known as hypotenuse. Okay, what the Pythagoras theorem tells us is that in a right angle triangle, the square of hypotenuse, which is our hypotenuse here, AC. So square of hypotenuse will be equal to sum in the sense addition, right? Sum of squares of other two sides. The other two sides are AB and BC. So square of them, AB square, BC square. Okay. Remember, we should always start with the hypotenuse. First, we have to find the hypotenuse, or let me take another figure for that purpose. And the common mistakes that the student does is, suppose, let's say this is right angle triangle. This is a right angle triangle. And suppose, let's say the value of QR is given as 5 centimeter and the value of PR is given as 3 centimeter and the value of PQ is in question mark. We have to find it. So a student might, most of you might solve it like this. Whichever is needed, you take PQ square is equal to QR square plus PR square. This is a big mistake. Okay. What does Pythagoras theorem tells us? The square of hypotenuse. So which is the hypotenuse? 90 degree opposite is QR. So we should always start with that. So the correct thing is QR square will be equal to PQ square. The other two sides. Apart from QR, which are the other two sides? PQ square and PR square. So PQ square plus PR square. And we have to be very careful when we write the statement of the theorem. What does the statement tells? The square of hypotenuse, square of, in a right angle triangle, square of hypotenuse is equal to, HYP is hypotenuse, okay, equal to square of, sorry, sum of squares of other two sides. This is the theorem. As I did now, if you just interchange this, instead of writing it as sum of squares, if you write it as square of sum, then it becomes like this. See, sum of squares is like x square plus y square. This is sum. Sum is addition. What are we adding? We are adding the squares. But if I say square of sum, this is sum and we are taking the square of it. So I hope the difference is understood. X square plus y square is sum of squares. X plus y the whole square is square of the sum. Okay, so you have to be very careful when writing the statement of the theorem. So let's prove this. Let's take a right angle triangle and let's prove whatever we have discussed. That is, square of hypotenuse is equal to sum of squares of other two sides. Okay, let's neatly draw the triangle. Let's erase all the stuff. Okay, just a second, let me erase everything. I'm a bit new to this. The following videos, it will be quick enough. Okay, so let's draw a right angle triangle. Let's complete it. So let's neatly draw it. Okay. So right angle triangle A, B, C. The right angle is that B. Okay. So what is given is the data or the given. We have given a triangle ABC in which angle B is 90 degrees. And what we have to prove is a very important theorem, might appear in the exam. We have to prove that square of hypotenuse AC square is equal to AB square plus BC square. This is what we have to prove. We'll make a small construction. The construction is from the right angled vertex, that is from B, we'll draw perpendicular. That is, let's take it as BD. Okay. So draw BD perpendicular to AC. Okay. These are the required things. Now let's start with the proof. First, the proof contains statement and reason, right? So first, we'll take the smaller triangle ABD. Let me shade it. The smaller triangle ABD that I'm talking is this triangle. Okay. This triangle that I'm shading. Okay. So this triangle and the bigger triangle ABC, let's try to prove that they are similar. So in triangle ABC and triangle ABD, observe in the bigger triangle ABC, angle B is 90 degree. In the smaller triangle ABD, angle D is 90 degree. So both are equal. And in both the triangles ABC and ABD, angle A is common. Angle A is equal to angle A, common angle. Therefore, the triangles ABC similar to ADB. Observe AB, AD, ABC, ABD using AA criteria. If two triangles are similar, we can say that the corresponding sides are in proportion. Therefore, we can write AB by AD is equal to BC, BC by DB, which is equal to AC by AB. Okay. Corresponding sides are in proportion. Okay. Let's, here what I'm going to do is I'm going to select the first one and the last one, because if you observe the numerator here and the denominator here are same, which implies let's select the first and the last. AB by AD is equal to AC by AB, which implies cross multiplying we get AB square is equal to AC into AD. Let's take it as equation 1. Okay, this is our equation 1. Similarly, let's do the other one. Okay, let's take another color now. Now I'm going to take the other smaller triangle. Let me shade it in a different color. As you can see here, triangle that I've shaded in green color. Okay, I'm going to take that triangle and the bigger triangle itself. Again, in triangle ABC and the other triangle is BCD. Let's try to prove that they are similar. Same logic. In the bigger triangle, angle B, and in the smaller triangle, angle D are equal, 90 degrees. Now, if you observe properly, in both the triangle, angle C is common. Angle C is equal to angle C because it is common angle. Therefore, the triangle ABC is similar to BCD. Okay. If you observe the B in the bigger triangle is equal to D in the smaller triangle. So B should be, okay, I've made a mistake. Let me, C is equal to C. So C is in the last, so C will come at the last. B in the bigger triangle is equal to D in the smaller triangle. So D will come here. The remaining thing is B. Okay, BDC. Okay, using AA criteria. Again, if two triangles are similar, corresponding sides are in proportion. So we get AB by BD is equal to BC by DC. That will be equal to AC by BC. In this, we are going to select the last two, because if you observe here, the numerator and here the denominator are same. So let's select those two. Okay. Implies BC by DC is equal to AC by BC, which implies on cross multiplication, BC square is equal to AC into DC. Let's take this as equation 2. So the last step, let me do it here. Adding equation 1 and 2. How do we add equations? LHS with LHS, RHS with RHS. Let me take a different one. Adding equation 1 and 2. So the LHS is AB square plus BC square. That will be equal to RHS plus RHS. AC into AD plus AC into DC. So AC into DC, AC into AD. Now, if you observe in the RHS, there are two terms, and in both the terms, we have got AC as common. Let's take AC as common. So we'll be left with AD plus DC. Clearly from the figure, let's watch the figure once again. Observe the figure. AD is this length and DC is this length. If we add this, we get the complete length AC, isn't it? So AD plus DC. So AC as it is, AD plus DC will become AC. Now what we have got is AB square plus BC square is equal to AC into AC, that is AC square. We can write the other way, which implies AC square is equal to AB square plus BC square. Hence, we have proved it. So let's look into the theorem. See, I have written the theorem in 3 different colors. So we can remember the theorem in 3 steps. That is, the first one is, take the triangle ABD, the one which is shaded in the blue color, and the bigger triangle ABC, and try to prove that they're similar. Once you prove similar, we'll get equation 1. Because corresponding sides are in proportion, therefore we get equation 1. If we do the same thing for the other triangle, the green color shaded, and the bigger triangle, if you prove the triangles are similar, we get equation 2. The third step is adding equation 1 and 2, we get the required result. So we can remember this theorem in a very, very easy way, and it's a very, very important theorem. So let's also look into the converse of Pythagoras theorem. What converse of Pythagoras theorem tells us is, let's write converse of Pythagoras theorem. So this theorem tells us that suppose we have got a triangle. Okay, let me draw a triangle like this. Let's take it as ABC. And let's say AC is the greatest one compared to all other side. Let's say AC is the biggest side compared to all other side. And if AC square is equal to the other two things, AB square plus BC square, if you have got a triangle which satisfies this relationship, then that triangle must be a right angle triangle in which the right angle is opposite to the longest side. So which is the longest side? The biggest side is AC. The angle opposite to AC is B. So B will become 90 degree. So if you have got a triangle in which this condition, that is the square of longest side, if it is equal to sum of squares of other two sides, then that triangle is a right angle triangle, and the right angle is opposite to a longest side. For example, let's take a triangle like this. Okay, let's take a triangle PQR. R, and let's say this is 5 centimeter, and let's say this is 3 centimeter, and let's say this is 4 centimeter. So which is the biggest one here? QR is the biggest one. So let's square it. QR square is 5 square, which is 25. Okay. Let's square the other two sides and add it. That is PQ square plus PR square. The other two sides, we are squaring it and adding it. PQ is 3 square, PR is 4 square. 3 square is 9 plus 4 square is 16. Therefore, we got 25. So what we have got here is, we have got that QR square is actually equal to PQ square plus PR square. The square of the longest one is equal to sum of squares of other two sides, which implies triangle PQR is right angled triangle. Right, RT represents right. Okay, I'm writing in the shortcut. RT represents right angle triangle. And where is the right angle now? The right angle is opposite to the longest side. Which is the longest side? 5 centimeter is the longest side. So the opposite to is P. So the 90 degrees will be here. So this is converse of Pythagoras theorem. Even we have got an exercise that we have to, the first exercise or the first question of the Pythagoras theorem exercise, that we have to check whether the sides are the measurements of a right angle triangle. And this, we have to do the same thing. Take the longest one, square it. Take the other two sides, square it and add it. If both are equal, then we can say it is a right angle triangle, or they are not right angle triangle. Let me take another example. Let's say we have got a triangle in which X, Y, Z. Let's say this is 6 centimeter, and let's say this is 8 centimeter, and let's say this is 11 centimeter. So which is the biggest one here? 11 centimeter, YZ. Square it. We get 11 square, that is 121. Take the other two things, XY square plus XZ square. XY is 6 square, XZ is 8. So 6 square is 64. 8 square is, sorry, 6 square is 36. 8 square is 64. So we get 100. So here we got the square of the longest side, we got it as 121. But the square, sum of squares of other two sides, we got it as 100. Therefore, YZ square, the square of the longest side, is not equal to the sum of squares of other two sides. Therefore, it is not a right angle triangle. I hope it is understood. This is the first problem in the Pythagoras theorem. Take it as a task and try it out. We'll continue with the problems in the next video. Thank you, students.